Heyo, this is Paleac, and in this tutorial I am going to talk a bit about clipping and using EQs and filters with really high resonances and gains to create interesting distortion effects and create self-oscillating, uh, self-containing oscillators within the filters, and just some sound design stuff that I've been playing around with lately that I thought was super interesting, and I'm sure you will too. So essentially what I have here is I have just like two sine waves, just literally just sine waves, and then I have this really basic rack of it's just an EQ. An EQ has really high gain and resonance, and then I'm using a spellbook here, which is a $20 Max for Live plugin that I'll explain a little bit more that you should get. And using this, I'm mapping all the parameters so I can create interesting movements and stuff. And then I can automate shit. So yeah, let's get into it, I suppose. And if you like the video, you can consider subscribing to my Patreon. You can get access to the rack I'm about to build in this video, as well as all of the racks I made in previous videos, samples, exclusive tutorials, and various other devices that I'm going to upload to it. But wait, there's more. I just started a Discord server. Wow. You can come join it, and then we can foster a cool community of music producers, and we can share sound design tips, give feedback, and just in general help each other improve at life and all your endeavors. I don't know. It's a brand new Discord server. Ideally, I would like to cultivate a small community of like-minded producers and people who are just interested in sound and who want to push the boundaries of sound design and make interesting experimental music. So, I would likely be sharing a lot of experiments and stuff that I've been doing behind the scenes that I otherwise haven't found interesting enough to make a full entire YouTube video about. So, yeah. Fun. So, if you take filter, you boost it a little bit. Notice when I move it quickly upwards, there's a little bit of a rising effect in pitch, right? And so if I increase the scale to 200%, that means instead of being plus 15 decibels, it's now plus 30. You can hear much more. So essentially, my understanding, and this is probably not really accurate, I need to learn a little bit more about how filters work and like the digital audio processing. Basically, filters are constructed using a bunch of little delays that are like tuned appropriately so that there is constructive interference and destructive interference for wherever you want it to appear. And essentially a high Q or a high resonance is a high feedback essentially for the delays. And so eventually if you like go over 100% feedback, it just turns into an oscillator. And so that's why if you listen to like acid and you hear an acid bass, then the really high resonance on the low pass filter that's moving around ends up sounding kind of like a note itself, as well as boosting the harmonics of the acid bass. So you can get interesting effects doing that, So you can already kind of see where I'm going. So essentially I am going to turn all of these guys on. And then I'm going to set all of the modes to be this little node thing. And then I'm going to put this into a group, activate all my macros. And then I am going to map the gain of all of these. I'm also going to map the Q of all of these because we're going to want to basically, actually, you know what? I'm not going to map the final one. because I want to have macro knobs for like the scale. If we map all 8 of these, then we're going to end up mapping all 16, and we're not going to have space for the scale knob, and this is going to sound just fine with, 7 instead of 8. And then I guess I'll have scale right here, and then over here I'm going to change the min and max. So I'm going to make it so that the min of all of these is 0. We don't want it to take away, we just want it to boost. And then the resonances, I'm going to make the min about 2, as going all the way to 0.1 isn't really helpful, and it takes up most of like the knob space, So now if I hit random, I can like randomize the like filter shit. Let's take a spellbook. So if you're not super familiar with this is a multi-mapping 2-dimensional LFO. The X and Y axis you can map to different things, and then this dot traces around the shape, and then the parameters map to the appropriate axis move around. It's really cool. I use it all the time. So I'm gonna map all the frequencies right here. Different stuff. Yeah. Now notice they're all mapped to the x-axis except for this guy, so I'm gonna change that. And I'm just gonna make it so that everything is doing something different. Okay. So now they're all the knobs are moving differently, but I wanted to move more different because this is still very symmetrical. Like this is just an inverted version of that one. So whenever this node is over here, the other one's going to be over there, etc., etc. So to do that, I'm just going to go open up, click on this knob here, or button here, to open up the phase offsets for each individual thing, and then I'm going to just like move the phase offsets to some random shit for all of these, and so it's going to get really unpredictable. So yeah, that's cool. And then oh, notice also you can still take away frequencies if you move the scale to negative. So think about it. There's like no need for this to go to 0. Anyways, now I don't want to blow my eardrums out, so I'm gonna add like a limiter here. Put this down a little bit. And then you can also add a saturator. I'm going to set scale to be excluded from randomization. That's a cool sound, honestly. Like a really interesting click thing. Like that. And now notice that that big clicking sound happens when the spellbook resets at the end of this loop and then loops back here. So notice this dot, it resets, it goes back here, meaning all the nodes fly back instantaneously, which creates like a discrete jump. So you can go into the automation for the spin phase, and then you can just like automate it around. I am going to group spellbook with this. No, EQ boost. Right. And then there's just the EQ boost rack, and then the spellbook controlling it right afterwards. Now we can start controlling the parameters of the spellbook, and then we can start kind of controlling like hyperparameters for how EQ shit works. So I'm just gonna map all the offset stuff here. And I'm gonna map all the ranges right here. Then I'm gonna map read and spin rate. And then I'm gonna map read offset and spin offset. And so now we can put this inside of another rack. First, I need to name these. This is the range. This is offset. Then we have read interval, read offset, spin offset. So now, using these hyperparameters, you can, like, you know, do shit like this. Like now, this is just gonna create a square wave. It's just gonna boost it massively and then clip it to all hell. So. That's fucking weird. Now I'm going to map the scale. So you can't map, for whatever reason, within racks, you can't, like, let's say, just map the scale all the way over here. You have to map the scale into the rack that's directly containing it, which is right here. And then from there, you can then map that onto the rack that's containing that. So it can't, like, skip a step. You can get around that if you use multi-maps, because a multi-map can map to anything. So for instance, if I wanted to, and I could, but this just, like, makes it a little bit cleaner and there's less devices, I could have a multi-map right here and then have the multi-map control some parameter directly in here, like, let's say gain, and then I can map the input knob here. The multi-map can actually map to literally anything in Ableton, so any other track, any audio effect on any other track, etc. So that's super useful, but I don't think we're gonna have to use a multi-map in this, but maybe. Now I'm gonna want to do a little bit more. I want to create a left and right mode. So we have this entire thing here. You can call this, like, resonance booster. I don't know. And then if we put this whole thing in a rack, and we map the parameters that we have been working with, and then we can duplicate this and create a left channel and a right channel. Hard pan this one left, hard pan that one right. I'm going to put a utility on the left channel, set it to be left. So this is basically saying I'm taking only in the left signal, which is made mono, and then it's being hard panned left. And then I'm going to do the same thing here. Now, something to consider is that you can hear the initial sine wave in the beginning, and I don't necessarily really want that. So to get rid of the sine wave and hear only the effects that we're changing to the sound, I'm going to pass in a phase inverted version of these signals. However, since I am adding the left and right signal together, and they're at the same volume, this is going to create a boosted volume of 3 decibels in the end. So that's just how the math works out. So I'm going to increase this volume by 3. So, like, if I get rid of the resonance booster here and the resonance booster here, you hear nothing, right? Now, the left and right signal, the left and right channels are both doing the exact same thing right now. So it just still sounds mono still. So I want to create a knob where I turn the knob and then it changes the spin offset and maybe even the read offset of the 2 signals relative to each other. However, I also want to be able to automate the spin offset of them separately. So we're gonna unfortunately have to use multi-maps, which I just said that we're not going to use. So that's cool. So let's take a multi-map. Well, let's just do it to spin offset first, right? So I'm going to take spin offset. And I'm going to map this multi-map to both of the spin offsets. Notice that I'm taking the multi-map, it's in the left thing, and I can still map it to the right one, right? So, like, right now there is a difference. These are offset by 10 right now, right? This goes from 10 to 100, this goes from 0 to 90. So when this is at 0, this channel, the right one is going to be offset by 0, and the left one is going to be offset by 10. When you turn it all the way, this one's going to be offset by 90, and this one's going to be offset by 100. So there's a constant, like, 10 number difference between the two. What we can do is I'm going to take min and map it here, the max and map it here, and then I'm going to invert it. So the max is going to go from 0 to 100, and thus, yeah, like if I bring it over here, be 40 and 60, 0 to 60, 40 to 100. These are going to constantly be offset by 40. Okay, so now there is a stereo knob. So I'm going to change this incoming source to something better, like a saw wave. Right? And if I increase the stereo knob, it's going to make it stereo. You may have noticed that there is some slight issue in that we have all these hyperparameters here at the end of the rack chain. However, nested within the rack, there inside the resonance booster, inside the EQ boost rack, there are all of these knobs that we can play around with and change. And that's kind of a headache to control. We're not going to be able to map all of these knobs onto the main rack to control from, from the top. And opening up several nested racks just to mess with these parameters and tune them is going to be just like really difficult and annoying. So I'm going to use another spellbook, and I'm going to map all of the parameters of these spellbooks to the gain, and then I think I'm going to have to use another one for the resonance, and then I'm going to map that to both of them, and thus we're going to only have to control 1 or 2 parameters, which will end up controlling all of these and creating like, random seed configurations. So yeah, so I'm going to put this spellbook in here and set the read and spin rate to off. Turn on reset so that everything is reset to the initial configuration. And then I guess I'm just gonna map this to all this shit. And then so the spellbook is pretty much used up, but I'm gonna make it so that these are all kind of randomized. And then we can even like hit ×2 on some of them, ×4. Make them even more different, right? Cool. And then we can do it again, but this time I'm gonna map to resonances, right? Now we're only mapping onto parameters in the left one, and we want to map onto shit in the right one. So let's move the spellbooks into the right channel. And then for every single parameter, you can map it to at least 2 knobs. So I'm going to open up this again, and then I'm going to map it over here. So now both the left and right band dudes are going to be having the same gain and resonances as each other, while we can still offset the phase for the spin rate of the frequency location of them using the hyperparameters that we created at the top. So map all this shit here. I'm gonna turn this into a more interesting shape. Let's use hexagram for instance. And then I'm going to have to create some more knobs. Then I am going to map the read offset and the spin offset of the gain spellbook to 1 knob, which means when I twist this, it's just going to completely randomize what's going on pretty much. So I can call this filter seed. And then, fuck it, let's do it with the other one as well. So the resonances and the gain are basically tied together, but it's going to be pretty much random at every point. And then I can even go in here and then offset the phase of the resonances to make it more different. So it's not like every time, a certain filter and the gain is like really high, then the resonance is also really high. Just like should completely randomize everything. Oh yeah. And then after that, I accidentally deleted saturator, but there's supposed to be a saturator right here. Which is fun. And then, if you change the mode that you're using to clip it, you get different results. If we go to the spin offset and automate this pattern, I can take the saturator and I want to put the saturator in the audio effect rack and then map the flipping type as well as the drive so I can get interesting distortion effects. However, right now this rack is splitting the left and right, so we're gonna have to put this into, you guessed it, another rack. Fun stuff. And then we're gonna have to map all this shit again. We can move the knobs around though if we want it to make a little bit more sense. So for instance, I'm probably still gonna keep range and offset, the first two, and then probably read offset and spin offset in the top near each other, because all of these basically are selecting what the filters are doing at any moment. Stereo is also pretty important in that regard. And then scale and filter seed. And then down here, read interval and spin interval are the automatic automation, right? So if this is cranked all the way up, this means that the spellbooks are not spinning. So then it's entirely dependent on your automation of the offsets. But if these are lowered at all, then they start spinning and moving on their own. Right? So it makes sense why these would be grouped away from everything else down there. And then we're also going to want to map now the drive, I suppose, as well as the type of filter. And then the saturator, I'm also going to map turn device on and off on it. Yeah, okay, I don't know why it is this way, but if I set the min to 1 and the max to 0, then that means when this is all the way at 0, then the device is off, and if it's at any other value besides 1, then it's on. So if I want an analog clip, then I just turn it a little bit. If I want to be on stop sign, then I turn it more, etc. And then all the way down here, it's off. Now, wave shaper mode is kind of interesting, because then you can start customizing and shaping your own distortion like wave. So I'll like crank the drive a little bit, and then you can play with these. And then let's go, and let's fuck with offset. You get some weird fucking patterns in there, just like that. I'm gonna name this clipping. For the most part, I think we're done. So I can call this iliac resonance clipper, right? Then we're also going to want to color these. So I want to like group things that do the same thing together, you know? So like for instance, read interval and spin interval are going to want to make the same color. And then distortion is red, obviously, as is the clipping type. Notice that we have 3 macro knobs remaining, and I need to find some things to map them to for efficiency. And so if we take a look at this phase inversion chain thing that we have here, which is canceling out the original sound. So, you know, if I play the sound, then I mute this phase inversion, you know, it helps remove the original input signal. Right, so that can be useful, and maybe you want to have the original signal come in. It's almost like a dry wet. So to do that, I'm just going to map the utility, gain from this utility here, and map that right here. I'm going to set this to go from negative infinity to 0. So yeah, so then I can name this, I don't know, invert phase. then the last two things that I want to map are actually going to be from the gain spellbook and the Q spellbook. So what I'm going to do here is I want to be able to map the offset of all these parameters for both of them so that I can nudge and change what the average like offset or average gain or the average Q resonance. So if I want them all to have a really high resonance in general, then I can move the offset all the way up, and then they're all going to be either at the max or close to max. So pretty simple. And I can do that here. Gain offset, and then this is Q offset. I can map both of those here. If you think about it, the filter seed is controlling what the gain and Q is doing. Scale is just multiplying the gain amount. So these are all pretty related to each other, so we can color them same thing. I can find what color was. Yeah, and then the invert phase, that's a weird one. I don't know. That. So yeah, those are all sounds we can get just using like a sine wave as the initial source. And then we can take this, go to our user library, and then throw it into our audio effect racks, and then we will always have access to this. Now I'm gonna play around a little bit, just try to create some more interesting sounds. Wrote this little melody thing here using just a sub bass, and then I want to take a little FFT spectrum thing. So I have this basic melody, and then this. So you can play around with these parameters and automate them. For instance, I didn't like how it was distorting on that note, so I could just lower the gain offset. Alright, that pretty much covers the tutorial. I hope you found that helpful. Yeah.